This is the 8th video of my series Casting Shadows, and this one's about boxes in the air and against the wall. This shows the frontal view of a box on the ground and a box in the air. I established 3 vertical poles here. Light goes through their tops, the blue lines go through their bottoms to give us intersections on the shadow. Now in this case, we get beveled edges because there are actually 8 floating corners, but these 2 cause this beveled edge, and these 2 above one above the other causes this beveled edge. Here are floating boxes with vertical sides. I chose this light direction and a horizontal shadow direction, and all the sides of the boxes have seats. Then it's just a matter of keeping your line straight. So if we take this back point here, it goes down to here, and we can see that the seat goes in the middle here, and we get this point right here. Here's a shadow that's both on the floor and on the wall, and I think you can see this construction. We want, for example, this point, follow the light ray to here, and the shadow line comes from down here, across and up, and we get this point right here, corresponding to the beginning of the seat. Now, if you move this chair this way, so it would be, let's say here, the shadow on the ground would get longer, but the shadow on the wall would get shorter. This is a box near a wall, and it's front-lit, so the pseudo-sun is down here, and the shadow vanishing point is here. So we find the shadows in the usual manner, so let's look at this vertical pull. A line goes toward the shadow vanishing point until it hits the edge of the wall, and then it goes vertically up to intersect the light right here. And since these poles on top are horizontal and not parallel to the wall, they form this arrow shape. This is an empty box against the wall, and let's just do the outside shadow. So we have this first pole that gives us intersection 1, and we have a second pole that gives us intersection 2. And we know the line has to go parallel to this horizontal pole, and it hits the wall at 3. But we don't know where to go from there, so we have to go around the other way. And I'm going to use this second diagram to show you. So we have this back pole here that gives us intersection 5, and this must be parallel to this casting surface up here, so it hits the wall at 6. Now we then use this back vertical pole here. The shadow line goes underneath it, it hits the wall, and then goes vertically up until it intersects the light at 4. So we have a line from 6 to 4 like this, which is cast by this horizontal pole. And then we connect 4 to number 3, and that's cast by this horizontal pole. Here we have one box on top of another one, and there's a vertical barrier in front. And we know it's vertical because there are vertical shadows on the vertical surfaces, and that only happens with vertical poles. So let's find the hidden corners of this bottom box. The shadow goes in the shadow direction, then vertically up, again in the shadow direction, vertically down, shadow direction. And the same here, shadow direction, vertically down, shadow direction. Now we can connect this pole with light rays to its shadow on the ground. So we get this shadow, and then the back part of the shadow is parallel to the casting surface. To finish up, we get the hidden parts of this box, and the shadow goes to the edge vertically up, and then in the shadow direction. For these box flaps, we can see that this shadow is from this flap, this shadow is from this flap, and this shadow is from this flap over here. So we need to set up seats. Not quite sure how low to make them, so go with the shadow direction. Go from a corner to the corner of the shadow here. That's one shadow direction going to the shadow vanishing point, and then another one is this corner going to this corner of the shadow, and that goes to the shadow vanishing point. So we set up the seats so that in order to find this point, we have parallel shadow direction, making this the bottom of the seat. And then it's just a matter of keeping your line straight. So for this one, we go down, we have a light ray going this way, and we get number 4. If we want number 2, for example, this point on the flap, we follow its seat down, shadow direction, and where it intersects the light is the corner. To find these shadows, we first have to do the wraparound to find the wall and ceiling vanishing points. So start at the floor vanishing point, go to the edge, then vertically up, and when you're level with the light, that's one wall vanishing point. If you continue up to this edge and across, the point on this wraparound vertically above the light is the ceiling vanishing point. So all these vanishing points are on the wraparound, and they have a vertical or horizontal relationship with the light. Now let's start with this rectangle, and you can see that it has 2 floating corners unattached to the surface through which light will pass, and we use this wall vanishing point to go through the 2 points that are attached to the wall, and that gives us 2 intersections. Now for this box on the ground, we use the floor vanishing point, and although there are 4 floating corners up here, 3 are important because they give us these intersections that form an arrow shape. And then these boxes on the ceiling are the same. I enlarged them over here. So they're just upside down. So light goes through the bottom corners, and the shadow goes through the top corners, giving us, for example, intersection 1. My next video is about shadows of open boxes. I bet you can't wait.